Welcome to the trapezoidal rule. So again, the idea here is we want to approximate the definite integral from a to b of f of x dx using n trapezoids. So if we draw a picture, here's my A and B. Here's my function f of x. And then we're trying to approximate the area under the curve between A and B. So we divide into n intervals. And then for each interval, we're going to draw a trapezoid, which has essentially base 1 extends from the x-axis to f, starting at the left-hand side of the interval, and base 2 does the same going from the right-hand side of the interval. So our two bases are essentially the height at the start of the interval and the height at the end of the interval to form a trapezoid. So we get a series of trapezoids that we can then add up and take the area of. So this is what we need to do. So again, here, if our trapezoid, so if we want to take the ith trapezoid, if we let x0 be A, then our xi's, I need to update my screen. Our xi's will be A plus I times delta x, where delta x is the overall width from A to B, so B minus A, split over n rectangles. So for our ith trapezoid, we will have essentially the height in terms of trapezoid terms is actually going to be our delta x. Our base 1 will be the height at xi minus 1, so f of x sub I minus 1. Our base 2 is the height at xi. Putting these all together, we get that the area of rectangle or of trapezoid I should be the height over 2. So delta x divided by 2 times the two bases. So times f of x sub I minus 1 plus f of x sub I. Now let me update my screen quickly again. So again, the area of the ith trapezoid is delta x over 2 times f of xi minus 1 plus f of xi. This is our generic formula for a trapezoid. So our area of a trapezoid is the height divided by 2 times base 1 plus base 2. So what we get here then is that our definite integral from a to b of f of x dx is approximately the sum from I equals 1 to n of delta x over 2 times f of xi minus 1 plus f of xi. We can, of course, pull that delta x over 2 out since it has no i's involved. Then we're multiplying by the sum from I equals 1 to n of f of xi minus 1 plus f of xi. It turns out that basically f of x0 will only pop up once in the I equals 1 term. F of xn will pop up once in the I equals n term, and everything else shows twice. So we can rewrite this as delta x over 2 times f of x0 plus 2 times f of x1 plus all the way up plus 2 times f of x2 all the way up through plus 2 times f of x sub n minus 1 and then plus just f of x sub n. So x0 and xn, the f value of those is just on its own. All the ones in between get multiplied by 2 since they will pop up both in the xi term and the or in the I equals blah term and then the next term as well. So essentially what we get, our formula is the definite integral from a to b of f of x dx is approximately equal to delta x over 2 times f of x naught plus 2 times f of x1 plus all the way through f of xn minus 1. That times 2, multiplying all the terms from f of x1 to f of xn minus 1. And then plus f of xn, where delta x is b minus a split over those n rectangles, so b minus a over n, and xi is a plus I times delta x. So x0 is just a, and then for each successive term after that, we're just adding on a delta x, the width of our interval. So this is our formula for performing the trapezoidal rule. In the next video, we will go ahead and do an example.